Last lesson was about showing you how to use TVM Solver. No word of a lie. TVM Solver is this topic. If you get good with it, you'll be fine. If you don't bother, well, you couldn't be bothered getting a good grade. So what we're covering today is exercise 7C1, 7C2, which is something called a future value annuity. If you save money for a future need, you generally build it up by making regular payments. If you remember back to the TVM Solver lesson, what did we do? We put like $5,000 in the bank and you let it sit. Who's the only people in the world that are probably able to do that?
Rich.
Rich people or old people? Not you. You don't have 5,000 to chuck in the bank and just leave there. You're not that loaded. So what you do, because you've got a job, you put little bits in at a time. And so what's going to happen? That account is going to grow because you're putting money in it. But because the compound interest is also growing slightly. That's what an annuity is, okay? When you have a situation where you make regular payments and grow it with compound interest, it's known as a future value annuity. We have to deal with two different kinds of situations, starting with nothing and starting with something. You can set up a future value annuity to reach a specific end goal by only making regular payments without a starting amount. So mathematically, if you're not starting with anything in the bank, what would PV be? Zero. You didn't chuck anything in there to start off with. Good. PMT. I am putting money in the bank regularly. So what would PMT be? Positive or negative?
Positive.
Take your time. Look, think back to the last lesson. Because it's going from you to the bank, it's going to be negative. And then FV, you're putting money into the bank over time, and at the end of the situation, the bank is going to give you that money plus the compound interest. What sign is FV going to be? Good. I've done this in black, but if you need help remembering that, you can chuck that on in your cheat sheet and do it in blue. Also, please remember the reason why I've given you this complex interest formula is because, well, you'll see why we need that here. So can you get this example down, please? Lewis deposits $600 each year into an account, paying 6% interest compounding annually. We want to find the value of the account after 15 years, and we want to find how much interest Lewis makes. So I'll give you a couple of minutes to get basically this stuff in blue down, and then we'll do the calculations together. What's the order of variables on TVM Solver? What's the top one? N. So get fast at going, when I need to show working out in this topic, I'm most probably going to have to type those things in. If A is asking me to find the value of the account after 15 years, what am I solving for? No, not the interest rate. FV. So put a star next to FV, or stars. N equals, let's leave that for now. What is the interest rate of the situation for Lewis? 6, and I don't need to convert. PV. Is Lewis starting with something in the account? No. So this is just a future value annuity with no starting amount. He's depositing $600 each year. So what's PMT going to be? Negative 600. FV is what I'm solving for. PY and CY. PY is the number of payments per year. CY is the number of compounding periods per year. If you look at the question, how often is he paying? Each year. And how often is it compounding? No, it doesn't. What does this say?
Annually.
Annually. How many times does a year happen in a year? Once. So 1 for both of those. So now we can work out n. I've got 15 years of payments times by, how many payments was it per year that you just told me? 1. So n is going to be 15. So now I've got my time. Press apps, enter finance, TVM solver. How do I use TVM solver? Enter the variables. Negative is the little bracketed negative at the bottom. Negative 600. FV is what I'm solving for. PY and CY are both 1. Alpha, enter. That tells me, but with this arrangement, I'm going to have $13,965.58 to 2 decimal points. Brackets, not numbers. Answer statement, therefore, the value of the account will be B. That seems surprisingly a lot, because is $600 a year really that much? No, it's not that painful. How much interest is paid? Interest is equal to, using this formula here, what it grew to. So it grew to $13,965.58 minus PV. Was there a PV? You didn't start off with anything, so PV is going to be 0. But unlike last lesson, was there a regular payment? There was a regular payment of $600, which happened 15 times. So do the working out. 13,965.58. Because you have a graphics calculator, you have access to brackets plus 600. And the calculator is aware of bed mass. So as long as you use brackets properly, you can trust it. So that tells you 496. That's not bad. The bank is giving you almost $5,000. But what's the disadvantage? You're losing $600 every year for 15 years. But that's a lot. Okay. Interest of answer statement is worth a mark. Can you get that example down, please? Just for curiosity's sake, how much money is Lewis putting in to that account over the whole time? He's putting in $9,000 to make over half of that as interest. So it's not bad. That's the power of compounding interest. Okay. Let's have a look at starting with initial investment. So hopefully you sort of logically get it now, how this TVM solver works. You can also start an annuity with a large amount to begin with and make regular payments on top of that. If you started with a certain amount in the bank, what's PV going to be? Positive, negative, or 0? Think about it. Good, negative. Because you put a giant chunk of money in the bank. So PV is going to be negative. If you're regularly putting money in the bank as well, what sign is PMT going to be? Negative again. And because at the end of it, the bank is going to give you all that money, compound interest and all your payments, what's FV going to be? Positive. Nope. Also, please remember to use that interest formula for investments. So we've got an example here. I'll read out the example and then I'll give you time to get it down. John made an initial investment of $5,000 into a savings account, followed it with regular deposits of $250 at the end of each month. The account paid 8% per annum interest compounding monthly. Find the account balance after 10 years. Find the interest earned. Can you get that down, please? And then I'll show you. If you sort of get it already, you can start trying to find it. But I'll do the example. NIPV PMT, solving for FV, PY. Let's have a look at John. What would I be for John's situation here? 8. PV. No. He starts with a negative $5,000. Well done. What now you can say? What's this? Negative 250. Let's have a think about PY and CY. How often is he putting $250 into the account?
Every month.
Every month. How often is it compounding?
Every month.
Yep. Now we can work out N. N is going to be 10 years times by however many times it was happening a year, which was 12. So it's going to be 120. So I'm going to go in the calculator now. Apps, finance, TVM, 120. 8, negative $5,000. Negative 250, 12 and 12, alpha, enter. If John was to do that, he would end up with $56,834.71, rounded to 2 decimal points. So even though he started off with a lump sum, $5,000 is maybe selling your car. $250 a month. $250 is like maybe a week, less than a week of work. So, therefore, account reaches B, interest is equal to $56,834.71 minus. Are there two aspects to the amount of money John is putting in? Did he put a big chunk in at the start?
Yes.
Did he put a lot of little chunks over time as well? He put 120 of those little chunks. So it's going to be minus $5,000 plus the 120 payments of $250. So it's 250 times by 120. That's the working out you would chuck in your calculator. 56,834.71 take away. In brackets, 5,000. Add 250 lots of 120. So the bank is giving him $21,834.71 in interest. It's not too bad. Although if you work out how much money he put in there in the first place, it's how much money did he actually chuck in there? 250 times by 120, add 500. 5,000, sorry. 35,000. It's still not bad. Yeah. But it's still not bad. You put 35 grand in and then after a while you're getting 56 grand. You didn't have to do anything for that. Okay? Can you get that example down, please? And we'll do one more example that covers the hardest element of this topic, which is changes of conditions. All right, let's talk about the hardest ideas in this topic. It doesn't actually change the maths that you do, it just gives you more steps. Which is annoying, but according to SACE, TVM solver questions aren't that complex because all you need to do is chuck the number into the variable. Okay? What SACE says is complex is when situations change. Did John's situation change at all over those 10 years? He just kept putting $250 in, okay? Lewis's situation didn't change. He just kept putting $600 in. The hard questions in our topic involve situations where conditions change. The problem with that is whenever conditions change, that means you have a new TVM solver for each of the set of conditions. That also means you need to do interest for each section. So if you had two different conditions, you're going to have two sets of this each time. So it's time consuming. So let's have a look at Jill, and then I'm done. Jill deposits $200 per month in an account paying 5.5% per annum interest, compounding monthly. Is she starting off with anything in there? No, she's just starting off with nothing. A, find the value of the account after 4 years. So we'll do A straight away. TVM solver questions. So N, I, PV, PMT, FV, PY, and CY. What's Jill's interest rate? 5.5. Did she start off with anything? Yes or no? No? PMT. What is she regularly chucking in there? 200. So what sign would it be? Negative 200. How often is she paying that money? She's per monthly and it's compounding 12 times a year. FV is what I'm solving for. Find the value of the account after 4 years. So 4 times by 12 is going to be 48. So chuck that into the calculator. 48. 5.5. Nothing. Negative 200. So that tells me she's going to have 10.57 to 2 decimal points after 4 years. Give you a couple of minutes to get that first part, eh? That first part needs to be done for us to work out the interest. How's the drone? I should have bet money on the drone failing.
They made us to write the song the whole time.
Yeah.
So you're,
My eyes are like watering.
Yeah, they should have recognized us around. Yeah. I guess they want
these people have paid money to make.
They probably want to go to like the school one.
So totally sick, bro. All right, let's look at B. Brody. After 4 years, which we've dealt with right now, Jill's money got up to $10,710.57. But after those 4 years, Jill gets promoted. She increases her deposits to $300 per month. What's the value of the account going to be after 3 years with the larger deposits? So, think hard while I'm typing this out before we decide what numbers are going to go into TVM Solver. Is Jill doing $200 for the whole 7 years? Has the conditions changed? Every change of condition, I need a separate TVM. So we've already done one. Now my question to you is, where does this next TVM start? Does it start off as 0 again? That's the point. I am telling you, this is the hardest part of this topic, because in your DI, to be able to push the highest grades, you need to show me a situation where there's at least 3 different conditions. But if I've shown you that you just break it up and you understand that I got my account up to this much, so that's where I start off the next time, it's not that hard. It's just time consuming, okay? So PV, how much did Jill get the account to after 4 years? 10 grand, $710.57. But where is this money right now? Is that in Jill's pocket or is it in the bank? So it needs to be negative, okay? Interest rate. You didn't say anything about the interest rate changing. N is going to be 3 years times 12, which is 36. We're trying to work out how much it's going to be when she's paying more. What is that more? She's paying $300 per month. FV is equal to, and PY and CY are still both 12. So calculator, 36 PV. I almost stuffed that up. Negative 10, $710.57. Negative 300. So you'll see that that's significantly more. 340.21 GDP after 3 years with the larger deposits. So we've done B. C, calculate the total interest earned over the whole 7 years of the account. Can someone try to explain to me why I can't just do that once? Let him, because you've been answering, yes? You have 2 TVM sections, and the other thing is, in this formula, how many spaces do I have for PMT? I've only got 1. How many different PMTs were there? 2. So I need to break it up. So first part, I is equal to, what did it get up to? It got up to $10.57 minus, it started off at nothing, plus 48 payments of $200. I'll just show the working. Second part, interest is equal to FV 24,340.21 minus, is it going to be 0 here? Question?
I think for the first part you did N and PMT around the wrong numbers.
Yeah, it doesn't make a difference. The order of, like, what's 1 times by 2? 2. What's 2 times by 1? Still 2. Okay.
Yeah.
Good spotting though, but yeah, it doesn't make a difference there. And then $10.57. I'll do it properly this time though, thank you. Plus 300 payments, $300 payments 36 times. So I'll do that working now. Second quit to get out of there. $10.57 minus 0 plus 48 times 200 is a number, and I'll also answer the second part now. 24,340.21 minus 10,710.57 plus 300 times $36. $1110.57. Does those two separate answers answer the question for C? What do I need to do those two numbers to get the answer to C? Good. So, total interest in dollars, that is that.